All right, let's talk about transformations. We've done this before. We're going to go kind of back over this again, hinging or attaching everything to our understanding of arrow diagrams here. So our main transformations, or the only transformations we really talk about, are either shifts, which is moving a graph, moving something up and down or left and right. Stretches and compressions, which means I'm either making it taller or shorter or wider or narrower. Those are the stretches and compressions. Or reflection, where I'm flipping everything over the x-axis or over the y-axis. Shift is also sometimes called translate. So we will hear that word associated with it. And there are certain mathematical operations that are associated with each of these types of things. So shifts are accomplished with either addition or subtraction. Our stretches and compressions are accomplished with multiplication or division. Okay, I'm going to call that add or subtract over there for some consistency here. Reflections are sign change. Okay. Which is accomplished by multiplying by -1 or dividing by -1. Either one of those would do that. So it's kind of like a stretch or compression, but accomplishes something different visually. Okay. When we talk about stretches and compressions, the number that we associate it with, we say, first of all, we have to specify whether it's a vertical compression or a horizontal compression. So that's the additional rows in this table, is that those transformations are either happening vertically or they're happening horizontally, or a combination of those things are going on. And we'll talk about that a little more when we get to the stretch and compress example here. So representing these with the arrow diagrams, we're going to work on a generic parent function that we'll just call f. Okay. So there's our generic parent function. We are making here a vertical, and it's important to note some things. The vertical we associate with the output, right? The vertical, the y-axis is the vertical axis. So this is our up and down, are words that we associate with this as well. Okay, so the output axis is the vertical axis. That's where we store outputs. So in this box that we're working in here right now, we're looking at vertical shifts. So it's a shift that affects the output. And so the arrow here on the black function f here with the arrowhead indicates that this right side of it is where the output is, and we are making a modification to the output. Okay? Now, adding a negative number or adding a positive number, I mean, that's adding a negative is just like subtracting. So we can, in our most basic form here, just say we're going to add some number k on there. Okay? The idea is that it's a shift up by k. We could describe it that way. What we get out of this, right, is, well, let's start with, let's throw an x in here at the beginning. So if we started with the x, the first place that x goes in on the first arrow into the set of parentheses, so that becomes an f of x. The f of x is the output of the black arrow, becomes the input of the green arrow, which says take whatever the input was and add k onto it. So this is what it looks like as a result. Again, the written description here would be a shift up k. We'll continue across here with vertical transformations. So here's our generic parent function, whatever it happens to be. We are doing a vertical stretch or compression. Because it's vertical, that's associated with the output. So again, we are modifying output side of things, so we need to add another arrow on the output side of our parent function. This is supposed to be something like a multiplication. So I'll use a as the multiplier. and just write that as a times some number. If that number is bigger than 1, then this is a stretch. If that number is smaller than 1, between 0 and 1, then this is a compression, because multiplying by numbers bigger than 1 makes things bigger. That's our idea of stretching. Compressing is making things smaller. So either dividing by a number bigger than 1 or multiplying by a number between 0 and 1 will make it smaller. Okay? So this is a vertical stretch by A. If we load the x in there, the x once again goes into the parent function, and then it gets multiplied. Something bad happened there. Let me undo a couple of things, and we'll fit it back in here. It then gets multiplied by the A. In fact, let me just try this again. I'm going to shift it over here a little bit. The x there goes into the f, and then we multiply in the front by a. So symbolically, this is what's going to look like when we vertically stretch a function by a. The reflection, parent function again. This is a vertical reflection, and so a vertical reflection is changing the vertical position. In order to do that, we need a horizontal mirror. So this is actually going to be a reflection over the y-axis. Okay, so a reflection over the y-axis changes the vertical position, and so this is a vertical reflection. And if we load our x in again at the beginning, the x gets put into the f, and the way we symbolize this, is just change the sign on it. Whatever comes in, whatever the output of the previous arrow is, we're just going to put a negative in front of all of it. Okay? And so this is what we get symbolically after a reflection over the y-axis. All right, horizontal. We naturally associate the horizontal with, this is the input axis that we use there. It's the x-axis. That's where we store our horizontals. This is about moving left and right. Okay. And so if we want to do a horizontal shift, we're again modifying a parent function. But this time we're wanting to shift left or right. We'll go shift right, because the right's where the positive numbers are. We are making a modification to the input. In this case, that means we need to change the beginning of that arrow, and so that requires an arrow that goes this direction. And it's going to look very much the same. I'm going to use an H instead of a K here, but this is our what it looks like to translate or shift to the right by H. Now, if I load that X in at the beginning, the problem is now that I don't have a path to get myself across here. These arrows are one-way streets. So I need to build a new arrow across here. I'm going to do it as a dotted line. It's not necessary, but for the video purposes, it'll help. And what goes on that is the inverse of what was on the other arrow. So this plus H, well, the opposite or the inverse of adding H is subtracting H. So when I load up the X, the first place the X goes is into this set of parentheses on there that says, first of all, subtract H, and now that is the output of the green arrow, which is the input of the black arrow, and so this becomes f of x minus h. That's the kind of output we get from a horizontal shift. All right, we should be able to move along nicely now here. So we've got our f of right there, and we are making a horizontal stretch. It's a horizontal is a change to the input. So the arrow is attached to the input side, and now we're multiplying there. And we drop the x in at the beginning to see what this looks like symbolically, but we need an arrow going back this other direction, and so the opposite, the inverse of multiplying by a, is either dividing by a or multiplying by 1 over a, however you want to interpret that. So the first thing that happens to our x is it gets multiplied by 1 over a, and then that is the output of the green arrow. It becomes the input of the black arrow, and we get something that looks like f of x divided by a. And then finally, if we are doing a reflection, this is now a reflection over the x-axis. You know what? I messed those up. If we want a vertical change, we need a horizontal mirror. The x-axis is a horizontal mirror. This one is going to be over the y-axis. So if you were screaming at the video there earlier, well done. Okay. So our y-axis is a vertical mirror. That's going to reflecting side to side, and that side to side horizontal motion then is a change to the input, and it's still a sign change. And when we drop the x in, though, then we need something going back this way. And it turns out that the inverse operation to changing a sign is changing a sign. If you changed it once, you change it again, you're back to where you started. So we start with the x. The first place it goes is into this green arrow, which says change the sign on that x. That becomes the output of the green arrow, the input of the black arrow. So this is f of negative x. That's what it looks like symbolically there. Okay, that's a lot of information in there, and we're going to want to keep track of that, because this is the title general transformations means that you can do this to anything. Okay, and we're going to try to demonstrate that and show how we can use that here. So, performing the transformations, okay, this says on this first one that what it wants me to do, let me get some of this other stuff out of the way, is transform y equals 2 log of 3x plus x squared by shifting to the left 4, reflecting over the x-axis, vertically compressing by 5, and then shifting up 8. Okay, well, where are we going to start? We're going to start with our parent function. Okay. And I'm going to make a nice long parent function arrow, because it's going to grab everything that was up here before. It's going to look like 2 log of 3 empty set of parentheses plus empty set of parentheses squared. Everywhere there was an x, there's now an empty set of parentheses. All right, our first transformation is a shift left 4. Left is horizontal. Horizontal is an input axis thing. So I need to add an arrow on the input side, shifting left 4. Left is where the negative numbers are, so that's subtracting 4. Reflecting over the x-axis. My reflection over the x-axis is a horizontal mirror, so that's going to make a vertical change, and so my reflection over the x-axis happens on the output side. There's the sign change. Then I am going to vertically compress by 5. Vertical is up and down, that's the output side, so that is another arrow on the output side. Compressing by 5 is either dividing by 5 or multiplying by 1/5. Okay, I can write that either way there. And then running short on color, so I'm going to borrow the green here again, shifting up 8, up and down again. That is output side, so this would be adding 8 on that side. Okay. And so I'm going to load my x in here. I'm going to have to change that to a +4. That's the inverse operation. And so I start with the x and add 4, That's going to give me an x plus 4 as an output right there. This x plus 4 is going to go into those sets of parentheses. So that's going to give me a 2 log 3 times x plus 4 plus x plus 4 squared. Then I am going to change the sign. That is the output of the black arrow, the input of the red arrow. The red arrow says change the sign on all of it. So I'll put a negative out in front. I'm not going to worry about simplifying right now. I certainly could. Okay. That is the output of the red arrow. It is the input of the blue arrow. The blue arrow says divide all of that by 5. Okay. That is the output of the blue arrow. It is the input of the green arrow. The green arrow says take all of that and add 8 onto it. Okay. And this then is my transformed function. Okay. Probably could have done what was on the black arrow in black. That might have been helpful there a little bit to see what was happening there. All right, not difficult. Again, there's some simplifying that could be done there, but I picked a fairly complex function to do the transformations to. Okay. Let's see what else we can do with this. Describing the transformations. Identify the parent function, describe how it has been transformed. So we have this. The way that I'm going to do this is I'm going to figure out where my variable was. It was an x right there, and I'm going to start with that. If I have the equation, I'm going to build beginning with the x. And that first arrow says subtract 1. Okay? So I'm going to take the x, I'm going to subtract 1 from it. That gives me an x minus 1. And then the next thing I need to do is divide by 3. I'm going to kind of throw some intermediate steps in here to make sure I'm building this right. So I see the x minus 1 over 3 right here that I've got there. That's good. That x minus 1 over 3 now ends up in the power of 7. So that's a 7 to the power, and I get 7 to the power x minus 1 over 3. And I see 7 to the power x minus 1 over 3. Because I'm talking about transformations, I'm going to do this negative 4 out in front here in 2 steps. I'm going to start by multiplying by 4. That will give me a 4 times 7 to the x minus 1 over 3. And I see that right there. Then I'm going to change the sign on that. That will give me the negative 4 times 7 to the x minus 1 over 3, which I can see right there. And then the final step is to add 2. Okay. Now, if I look at the arrows that I have here, I've got adding, subtracting, sign change, multiplication, division. All of those things are transformations. This, however, 7 to the power is not a transformation. So my parent function, okay, the parent function here is 7 to the x. Okay. That's all right that the parent function is f of x equals 7 to the x. And now I need to describe some transformations, which means I'm going to need more space than I left for myself here. Okay. I'll move all of this stuff down a little bit. Okay, I'm going to go ahead and start on the input side. What I need to describe is the transformations as they are being applied to the parent function. So on the input side of the parent function, the first transformation would be described by this green arrow, which I know has to be the inverse operation to the dividing by 3. That's a multiplying by 3. Okay, that is a horizontal stretch. By 3. Okay. The next thing that happens in the horizontal is going to have to be adding 1, so that is a shift to the right 1. Okay? In that order. Has to be in that order. Okay? My next ones I can see are already lined up in order, so I'm just going to describe them as I see them on the output side of the parent function. So there is a vertical stretch by 4, a reflection. This is a reflection that changes the vertical, so there must be a horizontal mirror. That's the x-axis. And then a shift up 2. Okay. So you're safe doing it this way. There are some other orders that would work here, but this one is absolutely correct. Okay. So 5 transformations were done to that parent function. Okay. All right, what else can we do with this understanding of transformations? Well, this wants us to sketch a graph of this h of x, where that is 2 times k of 3 minus x minus 1. Okay. And this is a graph of k over here. So I'm given the equation, so I'm going to start with the independent variable with my x. And the first thing that I see happening to the x is it gets a negative sign in front of it. So I'm going to do a sign change. That will give me the negative x. And then if I add 3 onto that, I get negative x plus 3, which is the same thing as 3 plus negative x, or 3 minus x. See that in there. That 3 minus x then goes into the function k. And that gives me a k of 3 minus x. I see that happening right there. That then gets multiplied by 2. So there is my 2k times 3 minus x right there. And then finally, I'll take all of that and subtract 1 from it. Okay. So I can see the transformations that have been done. I can read them off here. This is a shift left 3. This is a reflection in the horizontal direction, so it's a reflection over the y-axis. And then I have a vertical shift by 2, or a vertical stretch by 2, and shift down 1. But how does this help me graph? Well, it helps me graph if I grab these points. If I know what happens to these points, I can connect the dots in the order. So these are the points on k. Here is the parent function. On the parent function, starting with a negative 1, an input of negative 1 gives you an output of negative 1. That's this point. Okay, I connect a dot then to the point 3 comma negative 1. So an input of 3 on k gives me an output of negative 1. And then I'm going to backtrack up here to an input-output pair of 1 comma 1. Then an input of 1, output of 3. And then finally down to an input of 3 and output of 2. Okay. Now I just do what the arrows tell me to do. This arrow says these outputs that are coming out of k here, to the output sides of the inputs of this first blue arrow, and it says multiply by 2. So that becomes a negative, or yeah, negative 2, negative 2, 2, 6, 4. These are now the inputs of the last arrow. The last arrow says subtract 1 from all of those, so that's negative 3, negative 3, 2 minus 1 is 1, 5, 4 minus 1 is 3. And on this side, I'm going to follow the arrows moving back this direction, which say subtract 3. So negative 1 minus 3 is negative 4. 3 minus 3 is 0. 1 minus 3 is negative 2, and 3 minus 3 is 0 there again. And then the final arrow says change the signs on all of those. So that's a 4, 0, 2, 2, 0. And what I have now is an input connected to an output on the transform function. So my first point's going to go at 4 comma negative 3. So I go over to 4 down to negative 3. That is going to get connected to 0 comma negative 3. 0 negative 3 is right there. That is going to get connected to 2 comma 1. So here's 2 comma 1. That is that one. That's going to get connected to 2 comma 5, which is all the way up there. And then finally, that will get connected to 0 comma 3. That is that one right there. And so this graph in green is the graph of 2 times k of 3 minus x minus 1. It accomplishes all of those transformations. I can follow it right there by creating a table for the parent function based on what I see. This is why when we do the parent functions, when we introduce a new parent function, we introduce the key points on that parent function so that when we do transformations, those are the ones that get lined up here in the middle under the parent function, wherever the parent function happens to show up. All right, I apologize for how long that video was, but there's a ton of good stuff in there, and I will stop now.